Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session we're going to be talking about scalar and vector quantities. So, what is a scalar quantity? It is a quantity which has size only. So, a scalar quantity has size only. A vector quantity has size plus direction. So, a vector quantity, it has size plus and direction. Yeah. So, scalar quantity has size only, a vector quantity has size plus direction. Vector quantities can also be negative, so they can be negative. So, the negative sign tells you the direction. So you don't need to have the actual direction, you can just have a negative sign. That tells me it's a vector quantity. Let's look at some examples. So, an example of a scalar quantity could be the speed. Yeah, so it could be 5 meters per second. The vector version of it will be the velocity. And it looks almost the same, but it's slightly different. It has 5 meters per second, but east. That's an example. Why? Because the east tells me the direction. Next of all, so we've got speed on one side, velocity on the other side. We've got something else. We've also got distance. That could also be a scalar. And the vector version of it will be the displacement. Let's put some examples. So the distance could be, 10 kilometers. The vector version of it could be 10 kilometers north. Okay, so notice you might have the direction in terms of, so the direction, it could be in different formats. You might see it as, it could be in terms of an angle for the direction, or a negative sign. So look out for those things to indicate if it's a vector. Right, so we've got displacement and speed. So we've got speed on one side, velocity on the other. Distance on one side and displacement on the other. And now, last of all, we've got some more examples of scalar quantities. So 2 more examples. Time is a scalar quantity because it has no direction. If somebody asks you for the time, there's no direction. The mass of the object is also a scalar quantity as it has no direction as well. You put an object on a scale, the mass of 10 grams, that has no direction. Vector quantity. Some more examples of vector quantities. A force is a vector quantity. Why? Because look, if I draw this arrow of 2 newtons, you see it's got the value plus the direction from the arrow. So this is a vector quantity. Also, acceleration is a vector quantity as well. Good stuff. So we've got scalar quantities here and vector quantities here. We've defined scalar quantities and we've also defined the vector quantities. Right, scrolling down. Let's say you're asked to draw some vector quantities. So the task is to draw a 50 Newton force acting upon an object eastwards. So you've got the object here. Here is my object. So this is the object. And we are asked to draw a force acting upon the object of 50 newtons. Right, you just don't do it willy-nilly. All you've got to do is you've got to decide a scale to draw your vectors. So first of all, I need a scale diagram. So let's just say I have 1 centimeter represents 10 newtons. So now I've decided my scale, I can then work out how am I going to draw 50 newtons. So for 50 newtons, I therefore need 5 centimeters. So I get my ruler out. So here's my ruler. Place it on the screen and I'm going to measure out 5 centimeters. So 5 centimeters from here. There we go. So now this corresponds to 50 newtons. Easy stuff. Yeah, so we've got to use scale diagrams when we're drawing vectors. Okay, now we've done that. Let's have a look at another example. In this example, we're talking about displacement versus distance. So, look at the following question. Well, it's not really a question. We've got point A over here and point B over there. If I take this path, the curved path, up to B, let's just say that is 20 meters. Yeah? That will be the distance. So the distance is along that path. So the distance will be 20 meters. But what about the displacement? To work out the displacement from A to B, I simply take a ruler and draw one complete line from A to B. There we go. There we go, one straight line. Here we go. So, but how much is that worth? Well, you need to use a scale to work out the value of that displacement. So we're missing the value of the scale in this question here. So let's say I've got 1 centimeter represents 2 meters. Yeah? So what's it going to be, the displacement? I simply take a ruler and measure the length of the red line. So right now it's going to be 8 centimeters. So I've got 8 centimeters here. So therefore, what will the displacement be? It will be 8 times by 2, because I know each one's worth 2. Therefore, it's 16 meters. So this value here is 16 meters. So yes, the distance is 20 meters, but displacement is 16 meters. So we can put down 16 meters over here. Right, we're missing one more thing. So it's displacement. We know it's a vector. I must have the direction. Okay, the next thing we're going to do is work out the direction of the displacement. I can simply do that by taking a bearing. So if I drop a line from the top and measure this angle over here, yeah, so if I measure this angle, it will be 50 degrees. So now look, I've got the size, which is going to be the 16 meters, but I also need the direction, which will be a bearing of 0, 5, 0. Notice in mathematics we take the bearings in this format. So the distance will be 20. It's if I go along the path. The displacement is 16 meters, the direct route, and I've used a scale to work out that value. And I need to have the 50 degrees to tell me the direction. So that's a good example of comparing distance versus displacement. Okay, easy stuff. Next of all, summary. So scalars have size only. Yeah, we did that at the start of today's lesson. Some examples are going to be, we've got mass, time, speed, and distance. Vectors have a size and direction. For example, velocity, displacement, and forces. When drawing vectors, we need to use scale diagrams to represent the size. So we've got to use scale diagrams to represent the size. When looking at displacement, we need to include bearings or angles to show the direction. So whenever I'm drawing them, so for example, if I've got a displacement in this direction, I have to tell you the value of it, and I've got to put the angle, which is in bearings. So I need to use bearings to show me the direction. That's it. Another cool session in GCSE physics. I shall see you next time for some more crazy content. Bye bye.